This is Daniel Coosbury, and in this lecture we are starting algebra. So there's a lot of stuff in this section that are going to be definitions and just kind of introductory things. And so for starters, we have the algebraic expressions, which are basically anything that has variables in it. So an expression can look like x plus 5 or x minus 3. Anything that has a variable, these x's here, we'll call an expression. Algebraic expressions are not terribly hard to evaluate. Evaluating just means that they're going to give you, or we're going to give you some sort of like, let x, this variable, equal a certain number, and then consider the expression as and evaluate it if x was that number. So the way I'm going to tackle this is I'm going to rewrite my expression, except I'm not going to write x this time. So I'm going to write 8 times something squared plus 17. So this is my expression. And I'm going to plug in 5 for x, and then evaluate that. And evaluate just means tell me what that number is. So from this, I got to rely on my order of operations to compute this, right? Or, you can stick it all on the calculator. Order of operations says do exponents first, so I'll do the 5 squared first, so 8 times 25 plus 17. 8 times 25 is that's 200 plus 17, which is 217. So that's really all you do for evaluating. You're given an expression, they tell you what the variable is equal to, and you just plug it in everywhere you see that variable. So here's another one. This one has two variables. There's an x, there's a y, and this says anywhere you see an x, plug in -1. Anywhere you see a y, plug in -2. So notice when I plug things in, so I'm going to go ahead and rewrite this. When I plug things in, I leave a little space with parentheses for my variables, and that's going to really help me see what I'm doing well, because there's going to be things with negative numbers and exponents where if you leave these parentheses out, you might actually do something wrong. So I'm going to plug in -1 everywhere I see an x. So there should be a -1 here and a -1 here. And I'm going to plug in -2 everywhere I see a y. So let's put -2 here and -2 here. And then from here, I can just keep evaluating and just this expression, and you just tell me what these numbers are. So let's tackle exponents first. So we have a negative, and then this is -1 squared. So this is just 1. -1 times -1 is 1. We can do this multiplication in the middle. Why not? Let's multiply 4 times -1 times -2. The negative signs cancel out. 4 times 1 is 1 times 2 is 8. So this is just 8 in the middle. And then we'll just do the exponents first on this third part. We'll do -2 to the third power. So -2 times -2 times -2 is going to be -8. Oops, I put an equal sign there. So this is going to be plus -8. And now I've got three numbers. Let's rewrite this as this is -1, this is 8, and this we can rewrite as -8. So now we got a really simple problem. -1 plus 8 is 7, -8 is -1. These two cancel out. So that's probably a better example of it, like a messy evaluate problem. But at the end of the day, anytime it says evaluate, it's going to tell you what the variables are going to be equal to in this case, and you just plug them in. I really suggest putting parentheses before you plug things in. That way these negative signs didn't trip me up very much. So the next definition we have here is an equation. An equation is just two algebraic expressions that are connected with an equal sign. So the word equal is kind of present in equation there, equation. So you have two expressions that are set equal to each other. So we've seen equations at some point before. And then a formula is basically an equation that just has some sort of real life context. So the variables have some sort of meaning. Here's the Fahrenheit to Celsius formula, where the F would be a temperature in Fahrenheit and the C would be temperature in Celsius. So we're going to do some stuff with equations and formulas in this section. So here's an example of what we're going to call a mathematical model, which is basically some sort of formula that is drawn from real life information, like real life data, and they take it and represent it as some sort of equation or a formula where things mean things. So let's look at, well, let's look at this mathematical model first. So this says the mathematical model, and by that it's referring to this formula down here, Here's a formula, the model. It describes the number of calories needed per day, F. So it calls F the number of calories you need per day. So that's what that is, the number of calories you need every day. And it's by females in age group X with sedentary lifestyles. According to this model, how many calories per day are needed by females between the ages of 19 and 30 inclusive with this lifestyle? So we've got this thing where X is the group number, which we're going to see on that bar graph, and F, so this is the group number, XX. F is the number of calories you need per day. Now, this bar graph has a lot more information than we need. It has a bunch of different age ranges. It has the number of calories you need per day. It also has the number of calories split up for males and females. So in this age range, the red bar is what females need and the yellow bar is what males need. But notice that our formula deals not with these age ranges, like these numbers in particular, but with the group numbers. So group 1, group 2, group 3, group 4. This is group X. So what we want to do is we want to find how many calories are needed per day by females. So we'll be looking, so this formula itself refers to females, but we'll be looking in this bar in a sec. Between the ages of 19 and 30 inclusive. So on our bar, the 19 to 30 range is group 4. So this is kind of what's going to be our thing of interest, except we're only going to look at the red bar when we're done. So let's use the model and find the number of calories that the females between age 19 and 30 need. So what we'll do is, since this is group 4 right here, we're going to plug that in for X, and we're going to do negative 82 times 4 squared plus 654 times 4 plus 620. So notice all I did was I wrote this because it told me that's what this model does. It's for this group, this red bar group right here. If I plug in 4, then I'll just kind of work that stuff out. I'm going to go ahead and just punch all this in my calculator exactly the way I wrote it, and I end up with 1924. So if you punch all this in the calculator with the parentheses and negative signs exactly, you get 1924. And this is the amount of calories that females between the age of 19 and 30 need. Now, or maybe it's an approximation. So the question then is, does this model underestimate or overestimate the number shown by the graph? So I think it's safe to say the number shown by the graph is precise, like this is what you need. And the model is going to estimate that because it's going to use a bunch of data and provide you with an estimate. So the question is this more or less than the number shown on the graph? Well, the number shown on the graph here is 2,000, which makes this an underestimate of what's on the graph. So basically, we can use this model to calculate whatever we wanted. If we wanted to know the calories per day for females in the 51 plus group, all we would do is replace this 4 with a 6 because that's group 6, and that's how we would do that. So it's a pretty useful thing to use for real life situations. We're going to do some more with expressions. Let's talk a little bit about vocab. We got different parts. If this is my whole expression, we have a few different parts, and so I'm going to use these terms a lot. The variable refers to any letter that you see. So the X and the Y there are the variable. The terms refer to each one of these pieces, these whole pieces that you're adding or subtracting. So like that's a term, that's a term, that's a term, and that's a term. The whole thing. The 3x squared is a whole term. The 2x is a whole term. The constant, it's about to get really messy, I think. The constant refers to the number, the term that doesn't have a variable, which in this case is this 5 right here. So everything else has a variable attached to it. The constant is the one term that doesn't have a variable. So if you see like several constants, like in an expression, usually you can add them all or subtract them all together. It's just a number by itself. And then the coefficient refers to the number that you multiply the variables by. So in this case, the 3 is a coefficient, the 2 is a coefficient, and we would actually consider this minus 7 as a coefficient. We could think of it as negative 7 in certain formulas. So these 3 numbers are coefficients. This is a constant. The term refers to the whole thing, and the variables are the letters. Yeah, here's a nice little messy diagram. Maybe that's helpful. All right, so let's do some talk about some properties, and then we'll use these properties in a second. So we have different properties in algebra. We have two called the commutative properties. One's for addition, one's for multiplication. Commutative property just means that you can switch the order of your two numbers or your two variables, and they end up meaning the same thing. So here we have a plus b equals b plus a. You can think of this as like if I do 2 plus 3, that's the same thing as 3 plus 2. So that's a property we're kind of used to. You can switch the order of addition. It doesn't matter. Both of those are equal to 5. So it doesn't really matter what order. In the same way, if you did 2 times 3, and that's the same thing as 3 times 2, you can switch the order of multiplication. Order doesn't matter when you multiply. The associative property is a property that tells you you can, when you're doing addition or multiplication, you can add certain numbers first together, or you can add other numbers together. It's more like the order of when you do things. So if I were to do 2 plus 3 plus 4, the parentheses say I'm going to add the 2 and the 3 first and get 5 plus 4 and get 9. So that's how, if I were to do it this first way. But the associative property says this is also equal to 2 plus 3 plus 4, where if I put those parentheses there, it just means add the 3 and the 4 first, 2 plus 7, and I still get 9. So when you're adding a bunch of numbers, you can add whatever 2 first you want. It doesn't really matter. That's the associative property. I'm not going to demonstrate that here because that's the same idea. Is you can multiply the first 2 numbers first and then multiply by the third one, or you can multiply the second 2 numbers first and multiply by the first one. Doesn't really matter. Now the distributive property is one that we're going to have to use now because we have addition and multiplication. And the distributive property says if you're adding 2 numbers together first and then you multiply them by a number, that's the same thing as multiplying each one of those numbers by that multiplier. So to give a better example, let's do maybe 2 times 3 plus 4. So if I were to add the 3 and the 4 first and then multiply it by 2, that would give me 2 times 7, or 14. But if I were to do what's written over here instead, I could rewrite this as 2. Let's use the little distributive bars. I could write this as 2 times 3 plus 2 times 4, which is 6 plus 8, which is 14. So the distributive property is actually something we're going to use a lot in algebra, where you take, namely, these two expressions, the 2 times 3 plus 4, and you multiply, and you change it to 2 times 3 plus 2 times 4. So that's really something we're going to use. And the same thing works for subtraction. Okay, so now that we have that, we can simplify algebraic expressions. So these directions are a little distinct from what we saw earlier. It said evaluate, which is when you plug in a number for your variables, and then you just tell me what the number is, like simplify that number. Simplifying expressions means that we want to have distinct terms, which means each one of our terms needs to have its own unique variable or kind of variable. And I'll kind of show you what that means once we do that. But right now, let's just assume that simplifying means let's go ahead and distribute that and expand that out, and then we'll combine some terms, and then I'll kind of tell you how we would know it was simplified. So we can do the distributive property here. We can take the 5 and multiply it by both those things. So this is equal to 5 times 3x and minus 5 times 2. So I just distributed there. And then there's this 12x that I haven't done anything with yet. Now if I multiply, this is 3 things, 3x's times 5, so they're going to be 15x's minus 10 plus 12x. And then now I want to combine some like terms here, so I have 15x's, and I'm going to add 12 more x's, so that gives me 27x's, and then there's a minus 10. That's going to be my constant here. So this is a properly simplified expression because each term kind of has its own unique variable. This term has an x, and this term is a constant. And there's no like terms that both have x's, like there's a term with an x here and a term with an x here. They've now been combined in the proper algebraic way, so we'd call that simplified. Okay, here's a little bit a messier one. We have two expressions here. And they're being subtracted, and we have some y's here. So we want our simplified expression should just have 2 terms. It'll have a y in it, and it'll have a constant term. So we got to do some work to get there. Let's distribute the 4 that way. And let's also do this. Since we're subtracting this whole expression here, let's distribute this negative sign. Let's multiply both of these terms by a negative because we wanted to subtract both of them. So when I do that, I end up with 4 times 5y, and then minus 4 times 3. And then I'm going to do minus 6y, and then minus 3. I distributed that negative sign. So instead of these both being positive, they're both negative now. And I multiplied 4 by both of these. So this is 20y minus 12 minus 6y minus 3. So now I can combine like terms. I have 20y's here. I'm going to take away 6y's. That gives me 14y's left over. And here I have the number negative 12 and the number negative 3. So negative 12 minus 3 will give me negative 15. And now I have a simplified expression because I have two terms. One of them has a y, and one of them has a constant. So there's nothing more I can do there. All right, how about a messier one? So now we have not only stuff with parentheses, we also have some brackets around there, which we'll just think about as more parentheses. They're just different shaped. And we'll do some stuff to simplify. The only variable I see here is a y. So again, when we're done with this, we should have two terms. One has a y in it and one's a constant. So the order of operations says let's do parentheses first. So I'm looking at the innermost parentheses first. And there's nothing I can really do to simplify that there. So now let's look at these parentheses, these brackets, and do whatever I can do in these brackets first. So I have 3 minus 4y minus 5. Let's take this minus sign and distribute it, just like we did last time. We're subtracting both those things. So we're multiplying each one of those things by negative 1. So if I rewrite this expression as 7 minus 4 bracket, it's going to be 3 minus 4y. Multiply that by negative 1. Then I'm multiplying this minus 5 by a negative 1 to make that positive 5. So it's kind of the opposite of what happened last time. The last example, we had a plus here, and it made it minus. This is making it a plus again. So I'm going to work inside this parentheses until I can't work anymore. So let's simplify. I got a 3 and a plus 5, so I can simplify that. 7 minus 4 bracket. So 3 plus 5 is 8, and then we have a minus 4y. Okay, so I'm done with what I can do in here because I've got my two terms. It's simplified. There's nothing more I can do. So now let's take this 4 and distribute it. Actually, this is a negative 4 because there's a minus sign there. Let's distribute it. Multiply negative 4 by both of those things. So this is going to be 7 minus 4 times 8 minus 4 times negative 4y. And here the minus signs are getting really frustrating because there's so many of them, which is why it's so important to note that this minus 4 is being multiplied by all those things. Okay, so now let's simplify some things. I've got the 7 still. I've got a negative 32. And then I have minus 4 times minus 4y. This is going to be a plus 16y. Almost done. I think we're doing things well. And then I need to combine some like terms. So I'll combine the constant terms. 7 minus 32 is negative 25 plus 16y. And there's my simplified answer. I got two terms, a constant and a variable term. So that one took a little bit longer. The big takeaway from here is, one, maybe there's two. Don't be afraid to write out your expression over and over again. Doing one thing at a time, even though it seems like a lot of writing, and it seems like it's going to take a long time. That's going to help you not mess up if you just do one step at a time. But also work, when you got all these parentheses, work from the inside first and then inside, and then work your way out, because that's how the order of operations work, is you work from parentheses and then you do the exponents and all the other things. So this is your introduction to algebraic expressions and how to evaluate them and how to do some things with formulas and equations and mathematical models.